So to make this a little more familiar, I'm going to start recording it from the student's perspective, from your guys' perspective. As you can see, I kind of already started. I was having trouble with the drawing tools, but this way you can see it exactly from your perspective, and it'll make it easier for me to know which videos we've done and which one we haven't done. And the goal here is for these videos to be me doing the entire tutorial in one go. All right, so in this model, we're going to be using, for this module, we're going to be using models for data. Oof, that got me tongue-tied. And we're going to see how we can use this data, these mathematical models to predict things coming up. So for example, and this is when I realized I didn't have my dots on, or my pen on. If we have all these dots, is it reasonable for us to predict when this point would happen? So we've already kind of learned about using dots to figure out this line of best fit. So now we're going to see when it's reasonable to do that. And that's going to have to do with the strength of correlation. And if you guys really need to, what I recommend is going into the guided notes to keep track of these. And I recommend using these for the test. That way you have nice, strong notes for the test. There's also little worksheets here for you to kind of understand what a predicted value is. So these are all very good tools on figuring these out, to get more practice. So if you need more practice to understand things, that's great. And this also kind of explains the difference between causation and correlation. It's a very weird thing to grasp sometimes, because you're like, well, if something's correlated, why is it not caused by it? So those are little tools. As we get further in, I'll show you guys how to use graph and the dot plot more. So let's get into this. So I haven't used this in a while, so that's why my slide narration is still on. That threw me off hearing that right now. All right, so we have all of this data here. So that's a lot of data, and it would normally take us a while to figure this out. So let's see here. During the summer, we have both these sets of information. Then plot the points. Okay, so we're going to have to plot these points all individually. So one good thing, if you're having trouble with this, what you can actually do is I think you can actually use the data plots here. So if you go to data plots, you can put in your data sets. Oh wait, we'll get into this later. I meant to go to data. You can copy and paste it onto a tool. So Edmentum actually has these really useful tools. And we can click plot, and we can actually see the dots here. I recommend zooming out so you have like a better idea of what these dots look like. You can change the spaces here. So if you're a visual learner, this is a good way to kind of go about doing it. Unfortunately, right now they just want us to then plot. So this is very, very tedious. So make sure you guys start doing this in advance. So we're going to do this. So we're going to go 10, 10, and then 8, 9, 8, and 9. And then 11 and 12, 11 and 12. And once you get a good flow going, it's not that bad. 15, 17, so 15, 17. If you really want, I guess you can always go back over here and see if there's an easy way to do it. I recommend putting the increments on 1 and just kind of, so increments is how much it's going to go by. And then we're going from 0 to 19. So I can put like 0 to 20. So you can see this here. If you really need to have a picture, you can always use that little tool right here for graphing, the graph tool. I'm just going to continue plotting it. Something 17, 15, 17, 15, 16, uh, 16, 18, 16, 18. Should be it, right? Yeah, 16, 18, 11, 11, 11, 11. 16, 13, 16, 13, 14, 15. And I understand your guys' frustration in this. You have to do a lot of just tedious work. And I find it even more tedious because of the fact that there's literally a tool in the other thing that does it for us. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cool. So I have all those done. And let's say I want to do table 2. So, so I haven't even gotten to the questions yet because of how tedious this work is. So positive correlation. Based on the data, she concluded that it's a positive correlation between an increase. Identify which of the two tables represents the positive correlation and which one represents the negative correlation, then plot it. So this one already looks like it's a positive correlation. Let's take a look at this next graph. So the beauty of this too is you can actually graph more data after you plot it. So I plotted this. I can then, there we go. I was like, I know there's a way to do this. If I want to do more data, is this not letting me do more data? It is not letting me do more data. So let's look at the other graph. So it's a good thing I got lucky on that one. I just assumed that they were both going to be positive, but it turns out they're not. So let's go into graph again. And if we were to graph this data set, this one also has a positive correlation. If we're looking at both of them, they both have positive correlations. Wait, did I graph the right one? I totally didn't graph the right one. Oh, that's right, because I click copy on the data point. There we go. So if we plot this one, we see this one has a negative correlation. So again, I got lucky because I picked the one that did have the positive correlation, but always make sure you know which ones you're doing. So read the question, learn from my mistake, and read your questions. So this should be the answer. So let's click submit. Incorrect graph. Didn't it ask us to do the correlation? Plot the dots. So this item lets you draw lines. Okay, I know how to do that. Then plot the set of points. So between the correlations, identify which of the two tables represents a positive correlation. Table 2. Then plot the data points from that table. This has a positive correlation. I plot the points on the table. Let's see what's going on here. That's the only one with a positive correlation. This one's a negative correlation. It's going downward. Then plot the data points from that table. So identify which one. So that's this one. I'm going to do 10 and 10. I must have had like 1 point off. 8 and 9, 11 and 12, 15 and 17, 15 and 16, 16 and 18, 11 and 11. Sorry, I know this must be boring for you guys. You guys are probably like, I missed it when you had the power to just skip answers. 16 and 13, 14 and 15. Ugh, that's probably one of the reasons. So if you make a mistake like that, all you guys have to do is go to select, click the point you messed up on, and delete it. And delete it. And delete it. Apparently, you can't use the delete tool. 14, or the delete button. 14 and 15. And the last one was 13 and 14. So let's go to 13 and 14. And that should be 10 points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's look at the graph. They look pretty similar to me. Select, show correct answer, and continue. Not sure why it's saying it's wrong. Looks exactly the same to me. So this is Edmentum being at its Admentiumus. If you guys see why it's not correct, let me know in the comments below. I did not see why that was wrong. All right. So the next thing we're going to learn here is this is called a scatter plot. So anytime you see these little dots here, this is what's known as a scatter plot. So that's why when I went, well, this was just data. Usually it says it. And a correlation just means some type of relationship between the variables. So this one is a positive correlation. The line of best fit we're going to see is a line that kind of cuts through the data. We've already done this before. So let's kind of go into modeling it with technology. So technology makes it very easy for us to be able to graph this. And we're going to show this using the tools. I can actually show you right now. So let's say I wanted to do this data. What I can do here is I can click relationship, linear, and I can just click line of best fit, and this makes my best fit line. I can do the same thing here. So here's my data. I already plotted relationship linear because we want to see the linear relationship. And we click line of best fit. And you see that's a negative line right there. Keep this in mind because it is part of the unit activity. So let's get into this. All right, so going into this, we have all of these data points. We want to see if we can make a line. So what we're going to do here is we're going to click relationship, click linear, and then we're going to click this best fit line. That creates the line for us. And if you look here, it tells us how strong that relationship is. So these points are really close to the line, so it's really close to a 1. The closer this is to 1, whether it's negative or positive. So in other words, R, let me pick a better color. R is somewhere between -1 or absolute value. So R is always an absolute value. I'm sorry. So R is an absolute value, and it's always going to be less than or equal to 1. If it's exactly 1, that means it's right. Every single point lies exactly on the line. If it's like further away from 1, so let's say it's like -0.002, that means that first of all it's a negative correlation, and it's the dots are pretty far away from the line. They're not that close to it. And that's all we have to do to show our line of best fit using technology. So I do recommend using this a lot. It comes in very handy, especially semester 2 when you have to do a lot of graphing. All right, so moving on. All right, so now we're going to try to figure out the line of best fit for this. Well, guess what? This is pretty hard to do unless you have some kind of tool or technology. And that tool or technology we're going to use is going into here, and we're going to do graph the data. And we want to graph all of our X's and our Y's. So I'm going to grab all of these. I wonder if this is going to work because this is done the wrong way. If it's not, we're just going to have to hand enter it. Yep, we're going to have to hand enter it. So the way we can do this easily, just know what your X's are. So 2, 3, 4, 5, 6. So that one's easy. So 2. Oh, I have to do it in pairs. 217. 2. And then I'm going to hit the tab button, 17. Tab, it goes to the next one, 322. 3, tab, 22. And then I'm going to have 4, 26. 4, tab, 26. Then I'm going to have 5, tab, 30. Go back over here, and I'm going to have 6, tab, 35. 6, tab, 35. I'm going to click plot, and I'm going to go to relationship, linear. I want to see the best linear fit. And this is going to give me the answer 4.4x plus 8.4. So 4.4x plus 8.4. And that's how we do this. So make sure you're using your graphing tools right here. Otherwise, this doesn't make any sense. And doing it by hand is way too complicated. So we're going to do correlation coefficient. The correlation coefficient, like I said, it's the absolute value. It's always an absolute value. And the closer it is to 1, the better it is. All right. So, for example, 0.9991, that's really close to 1. So that's a very strong correlation. And this one has a strong negative correlation. This one has like a weaker positive correlation. So it can be strong and negative, as well as being weak and positive. Or I guess they're calling it moderate. Weak, I guess, is when the dots are everywhere. So let's take a look at this. So graph A. So we're going to do from strongest to weakest. So remember, strength has to do with how close it is to the line. So the closer it is to the line, the better. So if we're going from weakest to strongest, B is very, very far away from the line. So we're going to do B, boom, weakest. C is really close, so that's the strongest. And then A is going to be our middle one. All right, next one. Let's take a look here. So now we're going to use this to make predictions. So that has to do with that line of best fit that we talked about. So the stronger the correlation, the more reliable it is to do that to do predictions. So if it's really close to 1, it's very reasonable. Remember we said that word reasonable? It's very reasonable to make a prediction using this graph. So let's move on to the next one. And so we're looking at this, making predictions. So earlier we found that, so this is our graph. And now we're trying to say, so this graph involved reading. So when we're reading, it's saying like how many days. So we're talking about pages that they're reading versus how many days. Once this gets to 0, they have 0 pages left. So if Sarah has 112 pages left after 12 days, so if she has a book, this book is 315 pages, and she wants to finish in 12 days. X is the number of days it takes her to read, and this is how many pages are left. So this is the pages she's on. So if she wants to finish in 12 days, we plug it into this formula, and it calculates how many pages she needs to read every day to be done. So line of best fit. Again, this is just rise over run here. So let's say we want the opposite. How many pages they have left? How many days will it take us to finish it? So you're going to plug it into the y. So you have to know your x or your y here. So it can be used for both, to predict your x or to predict your y. Let's get some actual problems here going. And if you guys feel that I'm doing this way too fast, again, feel free to leave a comment on the video, and I can always like do an additional video to kind of fill in the blanks. So right here, we're trying to figure out, so X is the number of commercials airing, and Y is the bedroom sets sold. So the more commercials they air, they probably want to sell more mattresses. Why pay for more commercials if they're not going to sell more bed sets? All right, so they're saying that it airs 11 commercials. So 11 commercials. So usually what I recommend doing, guys, is identifying your variables. So X equals commercials and Y equals beds sold. Sold. I don't know how to write anymore. So if we're talking about how many commercials, then we're going to say y equals 2.14 times 11 plus 3.57. All right, so let's plug this into calculator. And I don't think I've used this enough on the previous videos, but they do have a pretty interesting calculator here. So I'm going to do 2.14 parentheses. Oh, this is why I don't use their calculator. What I recommend, and I started recommending this for all my classes. I know I always recommended the Google calculator, but there's a new calculator in town now that I know how to use it, and that's the Desmos Scientific Calculator. So what I usually recommend, guys, is bookmark this. Go into your Chrome, hit this, and bookmark this tab. This will allow you to have it for later use later on. So what I'm going to do here is I'm going to go in and I'm going to enter 2.14 parentheses. The first one, 11. Oops. Be careful when you're switching tabs because for some reason Desmos hates it when you switch tabs. Plus 3.57. And we see here that our answer is right here, this 27.11. So 27 is going to be our best approximation. And that's because we can't sell 0.11 of a mattress. All right, and let me clear the board. All right, so that's all we're doing here. We're using the line of best fit to figure this out. And you can see it's a pretty strong relationship. So we can safely say 27 is going to be a good amount to say here. All right, so So let's take a look. Equations for lines of best fit. So here's a new one. So again, we have to figure out these correlation maps. Well, in order to do that, what we're going to do here is we're going to open up our tool. We're going to go to graph. We're going to input our data. So 48 and 69, 48, 9. Next one is 72 and 57, 72, 7, 50 and 65, 50, 68 and 57, 68 and 57, 63 and 58, 63 and 58, 57 and 62, 57 and 60. Did I say 62? We're going to plot this. Then we're going to do relationship, linear, do best fit, and it's going to do all of the math for us. So negative 0.511. So we're going to do negative 5.11. I think I said 0.511. My bad. And 21, 91.6, 91.636. Correlation coefficient is going to be negative 0.67, 672. 72. Be careful to make sure that it's not highlighted when you go back because you don't want to delete it by going boop. I just Control Z to put that back there. So let's submit this. Why are they being picky here? Oh, it was 0.511. That was my bad. Negative 0.511. 91.636. And negative 0.96. 72. All right. Why are you being picky? Oh, they wanted the absolute value. They don't care. So they want the absolute value. They just care about how strong it is. To be honest, guys, it doesn't matter if it's negative or positive. If it's closer to -1, obviously that's a strong correlation. So it's fine. Next thing we're going to do here is based on the line of best fit. Can we expect the speed? So we're looking for the speed if he throws 80 pitches. About how many pitches? You can expect the average rate to be about. So we're basically looking at the slope, miles per hour. So based on the number of pitches, about blank. So we're looking at using our best fit to complete the statement. Based on the line of best fit, Luther can expect the average speed of his pitches to be about this much. We're looking at the average, so I'm assuming we're looking at the rate of change. 0.55 to be that much. Oh, okay. This is like a super backwards way of saying it. So if he's pitching 8 games, how much is his average pitch speed going to be? So we need to figure out our variables. And because I didn't read the question, I don't know what the variables are. So X represents the number of pitches. So X is number of pitches, meaning that our Y equals average speed. And let me scroll up here. What I'm going to do here is write this equation down. So negative, or actually I have the equation over here. So we're going to enter this into a calculator. Going back into mouse mode. We don't really need to enter the y because that's what we're solving for. So I'm going to do this as negative 0.511, parentheses, he's pitching 80 pitches, and the correlate, or the, I'm just going to copy this. Luckily, Desmos lets you copy it just fine. The only thing that really changed here was this is 80. And we see here that our y is going to equal about 51-ish. So let's see what we got here. About 51 miles an hour. And if his pitch is, so this is our y now. So now we're going to have to enter our y and solve for our x. I doubt Desmos is this fancy, but let's find out. Ba, ba, ba. And we are going to make this 64. Yep. Desmos is not that fancy. So what we're going to do is I'm actually going to solve this on Desmos to kind of make this easier. I'm going to subtract 91.636 from both sides. By subtract, I mean eliminate that. And I have to divide. So I'm going to highlight all this, hit the little division symbol on my keyboard, or you can just hit the division symbol here, by negative 0.511. That's going to get our x by itself. And it doesn't like the equals x. It likes the equals y for some reason. But our average pitch is going to be 54.082. So 54. So let's get this going. We're going to do this 54. Ooh. There we go. So that's how you can use Desmos. You can see how they worked it out here. This one they just plugged in. I just used the calculator. Here, since we can't solve for it by only plugging in y, I had to reverse do it. So I subtracted and then I divided. All right, so let's see what we have here. So next one, what does the absolute value of the correlation coefficient help us predict? So let's take a look. So it's a strong correlation. It's 0.96. So closer the R is to 1. I should say the absolute value of R. I'm just going to use the little lines on the keyboard here. The closer the absolute value of R is to 1, the stronger the relationship, thus it is more reliable for predictions. Prediction. That's all we're saying. How do you know? Just because it's stronger than that. Do one or two sentences. I did one. Rate how you did on here. Um, I would give myself a 4. I made some mistakes with decimal places. This was easy because of Edmentum. And I think honestly thinking that's the best way to do it. Back when I did the math, they actually taught us how to calculate R. It's a pain. Just be grateful you don't have to calculate R. Let me submit that. Oh, I forgot to submit this. I was like, how come I can't go to the next one? And our summary. So make sure you guys are reading what R means. A lot of this we kind of covered in our last section, and this honestly helps you out a lot when doing your guided notes. Go here and learn about that. Let's go to the next one, and we're going to save and exit so I can get credit for submitting that. Yay. Alright, guys, so hopefully you like the new format of me doing it. I know this one had a bunch of tedious stuff, but after that, using the tools made it easy.